So let us now find the value of tangential acceleration. So tangential acceleration will be in tangential direction, which is this direction here. Now, the component of kx along tangent will be kx sine 60, and the component of mg along the tangent. So the component of mg along the tangent, it will be like this, mg sine 60. So our equation for tangential acceleration will come out to be by Newton's law. We will have kx sine 60 plus mg sine 60 is equal to mass into tangential acceleration. So our equation for Newton's law will come out to be kx sine 60 plus mg sine 60 is equal to mass into tangential acceleration. So from this, solving this equation on putting k as we have the value mg by r, x as r by 4, we will get the value of tangential acceleration at. On solving this equation, we will get 5 root 3 upon 8 into g. So our final answer to this question, tangential acceleration is 5 root 3 upon 8 into g. So this is how we solve this question. Now, moving on to our next illustration, which is illustration 36. So in this example, we are given two masses. Let us say M1 connected by a spring having spring constant K and another mass M2. There is a force which is applied in vertically downward direction on mass M1 as shown. Due to this force, what will happen? The lower disk of mass M2 lies on the table, and the upper disk, we are applying a force. On applying this force, there will be a force which will be transferred in the spring, and the mass M2 will be lifted from the ground. So this mass M2, which is kept on the ground, due to the spring force, after some time it will be lifted off the ground. So in this case, we have to find what vertical applied force should we apply so that the lower disk is lifted off the table. So this M2 mass must lose contact. It must lose contact. So to lose contact, in this case, what will we have? So in this question, we are asked the value of force F on M1 so that the lower mass loses contact with the ground. Now, let us consider the free body diagram of upper block M1. We have a force F which is acting in downward direction. So there is a force F, external force F acting in downward direction, M1G force acting in downward direction, and a spring force Kx acting in upward direction. So this is the spring force Fs. Now, from this, if I apply Newton's law equation, we will get, in this case, the upward forces equals downward forces. So the upward force, only upward force is spring force Fs, whose value is Kx, and downward force is M1G plus capital F. So this is equation number 1 on body M1. Now, after this, let us come to equation number 2 on body M2. So for M2, we have one force which is normal reaction, another force which is M2G. So M2G acts in downward direction, normal reaction acts in upward direction, and spring force, in this case, for M2, it will also act. And the spring force will be in upward direction, Fs. So our equation for Newton's law will become, so this is for M1, this is for M2. Newton's law equation is Fs plus N upward forces is equal to M2G. Now, for block M2, to lose contact, we'll have normal reaction 0. So to lose contact, the condition is normal reaction becomes 0 to lose contact. So our Fs value equals mg. And whose mass it is? M2. So here we will have M2G. So Fs equals M2G. Let us substitute in equation 1. So one equation will become M2G plus M2G equals M1G plus F. So from this, the value of F comes out to be M2 minus M1 into G. So F comes out to be M2 minus M1 into G. So the final answer to this question, the value of F equals M2 minus M1 into G. Now, let us move on to our next question, which is illustration 37. So in it, we are given two cases, case A and case B. So let us see the diagram for each cases. So in case A, we have a spring of spring constant K. We are applying a force on this F here, and this is point P. And this is also a ground. This is a wall here, and we have a ground at the bottom. So let me show the other string here. The diagram is something like this. Now, in the second case, we are applying a force here, F, at point P. Now, in this case, due to this force F, we have to find the force F value in terms of spring constant K and displacement Y. So we are given spring constant K in both cases, displacement is Y. So we have to find the force as a function of Y and K. So let us first take case A. So in case A, at this point P, we have one force which is F, and we also have another force which is tension, because point P is on a string. So there will be tension in the string. So first equation for Newton's law will be F is equal to tension T. Now, for this pulley, we will have two tensions like this and one spring force Fs in upward direction. So, for the pulley, we will have a diagram like this. 2T is equal to Fs. So, for the pulley, we have a diagram like this. So, we have 2T, T and T is equal to Fs. Now, Fs will be in this case K into Y by 2. So, why Y by 2? Because total displacement is Y. Y by 2 on the left side, Y by 2 on the right side. So, total displacement is Y. So, 2T is Fs, that equals K into Y by 2. So, we have found the value finally. So our value for F is T, and from equation 2, T is equal to K into Y by 4. So our answer will be F is Ky by 4. So this is how we'll solve case A. Now moving on to case B. In case B, we have various forces. Let us consider the pulley. We will have tension force T, but this tension force will be equal to spring force because spring and tension are connected together. So T is Fs. So T here is also Fs. And here we have force F. So from this we can say for the pulley we have Fs force in upward direction here, Fs force in upward direction here, F force in downward direction here. So from this we can say F is equal to 2 times Fs. But what is the value of Fs? Here, so here if I write Fs equals K into 2y. Why do I write 2y here? So first let us mark this equation. Fs is K into 2y. See, in this case, we have a extension y in the spring. We are given displacement y of the spring. So displacement y of the spring, in this case, y on this side and y on this side. So total extension will be 2y, y plus y. So Fs is K into 2y. So let us substitute the value of Fs. It is K into 2y. So the total force value F comes out to be 4Ky. So our answer in case B comes out to be F is equal to 4Ky. Why do we have 2y extension here? Let me explain once more. So in this case, we are given the extension in the spring is y. So this is the extension in the spring. So let me show you by spotlight. This is the extension in the spring y. But this is extension in the spring y on this side. So there will be extension y on the other side as well of the spring. So y on one side, y on one side. Total extension will be 2y because the spring is extensible, but the string is inextensible. So y extension here in the spring is also transferred y in this direction. So y, let us say due to this extension y, if this pulley moves down by y, so let me show this pulley moving down by y. So this pulley is moving down by y. So this side also there will be y downward direction. So total, as the string is inextensible, y and y, total extension in the spring will be y plus y, 2y. So hence we have this 2y value. So the force is coming out to be 4Ky. So this is how we solve this illustration 37. So after this, let us move on to our next illustration, which is illustration 38. So in illustration 38 we are given two masses. So this is the ceiling and we have a mass 2m here, and we have a spring here connected to a mass m. So two blocks are connected by a spring. The combination is suspended at rest from the string attached to the ceiling as shown. Now it is given the string breaks. Suddenly string breaks. Find acceleration of the upper block of mass 2m. So we have to find the acceleration of upper block of mass 2m. Now, as soon as this string breaks, the spring will still have a spring force. So in this case, let us consider the free body diagram. So before string breaks, tension T in the string in upward direction, kx naught spring force in downward direction, 2 mg weight of the body in downward direction. So Newton's law equation is P is equal to 2 mg plus kx naught. So this is Newton's law equation. Now, after the string is cut, what will happen? So in this case, there will be no tension force and there will be acceleration. So 2 mg plus kx naught, there will be no tension force here. Instead of this tension force, now it will be accelerating in downward direction. So it will be mass of the body 2m into acceleration a. So from this, I can say 2 mg plus kx naught is equal to 2 ma. Now, for the lower mass, we have one force kx naught and mg. These two balance each other. So I can say kx naught equals mg. So let us substitute this value kx naught is equal to mg here. So 2 mg plus mg is equal to 2 ma. So a comes out to be m cancels 3g by 2. So our answer to this question, acceleration is 3g by 2. This is the answer to this question.